David Smith here with yet one more Flipped Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit you. You can also pause a video at any point and jot down notes or write down questions for our next class. Lastly, you can turn on the captions and read my words on the screen. Today's topic is the compound interest formula. So in the last exercise set, you found all the compound interest by doing these kind of chain multiplications. Now we're going to use that idea and we're going to have a formula that's going to make that calculation a little bit more direct. But formulas have their challenges. You've got to do a correct plug-in step. If you don't do that right, you're not going to get the right result. So I'll show you that in a minute. But first, let's take a look at this formula. It's got a lot of terms in it. FV equals PV times 1 plus R to the n. So there's your formula. Now let's break it down. FV stands for future value. This is the amount in the account after the period of time is gone. So if you invested it for 3 years, then the future value will be the amount in the account at the end of 3 years. The PV is the present value. That's the starting amount. That's what you put in the account initially. That's the amount that starts earning interest. 1, that's 1. R is the yearly interest rate as a decimal. So if it says 6%, you've got to put 0.06 there. And then finally, N is just the number of years. So if the investment is 3 years, you're going to put 3 there. And notice that this is 1 plus R raised to the n power. Okay? Now, I haven't talked about the multiplier, but it's here. Think about it, look at that equation, and see if you can tell me where the multiplier is. Okay, check this out. 1 plus R is the multiplier. Okay? It's a shortcut. We don't use the percentage addition stuff and change to a decimal. It's going to be a decimal right away. Here's the 1, and then the R is going to be some decimal interest rate. Okay, here's an example. I'm going to walk you through that. $2,000, let's put our dollar sign on there. $2,000 is invested at 7%. How much is in the account after 4 years? Okay, so as I mentioned before, here comes the plug-in step. Super important to get this one right. Future value, this is what we're trying to find. This is our unknown. It's going to be the present value, that's the 20,000, times 1 plus R as a decimal. So 7 as a decimal, 7% as a decimal is 0.07. 1 plus 0.07 to the n. The n is the number of years, so that's to the 4. Okay? Now that's my correct, complete plug-in step. Now we just have to simplify. So FV is going to be 20,000 times, now 1 plus 0.07 is just 1.07 to the 4. Now you have to remember your order of operations here. I have to do my exponent first. So let's do that. 1.07 to the 4th power gives me 1.31. So let's just write that in there. FV equals 20,000 times 1.31. And now I can do my final step. Times 20,000. And I have 26,215.92. 26,215.92. And that's the amount left at the end of the account. Okay, here's one for you to try. $250 is invested at 9% for 15 years. So let's see how that comes out. What I want you to do is pause the video, use the formula and the numbers in the question to do your plug-in step, and then work that through and see what you get. Okay, let's do it. Future value equals present value, 250 times, now I'm going to combine this a little bit, 9% is 0.09 plus 1, we're going to get 1.09 to the 15th. Now we can get out our calculator, and I can do this in one step. 1.09 to the 15th power That gives me 3.64. I'm just going to do times 250 equals. So at the end of this period, we have $910.62. So not bad. This amount more than tripled. Of course, it was in there for 15 years. That's a long time. But you'll find that this amount is quite a bit more than if we had just done simple interest for $250 at $250 for 15 years. So just to compare, let's do that. Remember that calculation is the interest itself equals the principal times the rate times the number of times. So that's going to be 250 times 0.09 times 15. That's going to be the interest. Let's do that calculation. 250 times 0.09 times 15. That's going to give us, interest is going to be 337.50. Add that to our 250. And this is $587.50. So quite a difference here. Compound interest got us all the way up to 910. If we'd just done simple interest for 15 years, we would only have 587. So this shows you why you're happy that when you make an investment in a bank, they're going to pay you compound interest. And what's more, and this is cool, we're doing yearly compounding, and that's as far as we're going to get. In reality, they do daily compounding. So every day, a little bit of interest is added to your account, and the next day, that new little bit of interest is adding more interest to your account. So daily compounding is the rule. Now that you've watched the video, take a moment to write down some notes or questions or a short summary of the lesson. You can also re-watch portions of the video that you didn't get so well the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.